Hello, this is Domenico with Easynomics, and this will be a continuation in a series of videos where I've been evaluating monopoly, both benefits of it and negative aspects of it. Those videos will all be linked in the video notes below. This particular video is going to look at inelastic supply in the context of the commercial aircraft manufacturing industry. In the previous video, which again will be linked in the video notes below, we looked at Boeing as an applied real-world example as a monopoly in the US market or duopoly in the world market as it competes with its European rival Airbus. And we graphed and analyzed that monopoly model and discussed how the drive for profit maximization, in this case with Boeing, led it to try to reduce its average total costs and thus its supply curve to increase its supernova profit. But that all came at the cost of the quality and safety of the Boeing 737 MAX aircraft model, which spilled over negatively to society in regards to airline crashes, which I'll also highlight in just a moment. We also connected it to asymmetric information, another type of market failure where the airline industry is demanding the 737 MAX with asymmetric information. They are not aware of its defective quality. And then as a result of two particular crashes and other incidences, investigations, more symmetric information is reducing demand by the airline industry for the 737 MAX. So this video is going to highlight how reduced demand for Boeing leads to the airline industry to start to switch to a safer alternative or substitute being the Airbus A320 family of commercial aircrafts. But again, this video is going to focus on the inelastic supply of both the Boeing and Airbus supply curve. There was also a previous video where we were not only just looking at the negative aspects of monopolies abusing power, but also can highlight how the supernova profit by a firm such as Google could be used to be invested into research and development, and that can lead to spillover benefits, such as all of us freely using Google Maps or Google Documents and other free online resources from Google as a result of their investments in research and development from their supernova profit. So that's a positive production externality, and there'll be a link to that video in the notes below. So with this inelastic supply concept, it's coming from an article. So there's a shout out here to Chris at Kaleidic World, which is a Facebook community for IB, Econ, and A-level teachers. He posted this article from the Financial Times, which discussed that although Airbus should be benefiting from increased demand due to the airline industry switching away from Boeing towards Airbus, there's still a limit in its ability to increase its quantity of supply, its revenue, and profit due to bottlenecks, due to the inelasticity of its supply curve. The article highlights that if we adjust the stock price, because Airbus stock is priced in euros, in US dollar terms, we could see that Airbus is taking a lead because they are the safer alternative to Boeing. Boeing releasing defective products that are unsafe, thus the airline industry is switching away from Boeing towards Airbus, which is a benefit to Airbus in this duopoly market structure. But the article highlights here that Airbus is not able to take full advantage of that increased demand because of restrictions on its supply chain. That has an inelastic supply chain due to bottlenecks in aerostructures, cabin equipment, and most recently, engines, to explain why it will deliver 30 aircraft fewer than planned this year. Airbus is planning to get up to a point where they're producing 75 A320 jets a month, but they're currently only producing about 50 a month. So it's going to take time, length of time, to expand their production, improve the efficiency of their production assembly line so that they can produce more output per unit of time. Okay? So Boeing 737 MAX in particular, there's been a series of accidents and incidences. Lion Air Flight 610 crashed October 2018, leading to the deaths of 189 people. And then not too long after, in March of 2019, Ethiopian Airlines flight also crashed, killing 149 passengers. All negative impacts on society, all a form of a negative production externality, and also a form of market failure due to asymmetric information. Recently, Alaska Airlines Flight 1282, I think a cabin door blew out. It was missing some bolts. So this all leads to the consumer, the airline industry, to really question the quality and safety of these airline models from Boeing. And of course, they're going to reduce their demand, because if they're using Boeing jets, in particular the 737, and it's grounded by government regulators, then the airline industry is losing the opportunity to use those aircraft to provide their service. So of course, they're going to switch to the alternative. In terms of orders and deliveries, here we can see that definitely Boeing's taking a hit. Here we have the 737 MAX, and in 2017, here over time we see the number of orders from 2011 onward. 2017, 774 orders. They were able to deliver 74 because they're just starting to release it. But here we go, 2018, we have the first airline crash. 662 orders, 256 delivered. But in 2019 and 2020, as investigations and concerns appear with the 737 MAX, here we see that there's a net decrease in orders. 2019, there were 47 orders, but 183 cancellations. The airline industries that had placed orders are now canceling. We definitely don't want that defective model. And then 2020, we see again, right here highlighted, there were 112 orders, but 641 cancellations of the 737 MAX. So airline industries reducing their demand. They're going to switch over to the duopoly Airbus. Airbus being able to provide, hopefully, a higher quality, safer commercial jet to the airline industry. In terms of orders, we scroll down here, we can see that where the Boeing 737 is having years of declining orders or canceled orders, we see a steady increase in orders for the A320 family from 2016, going from 68 to 181 to 386, 551, and so on. So it's a steady increase. Airbus is positioned here to become the market leader in this industry for airline manufacturing. So let's get into the model. So in the top left corner, I've posted an image from my previous video where we linked Monopoly, here Boeing in graph A, Monopoly in the US market, Duopoly in the world market. We graphed it, we analyzed it, we highlighted the supernova profit maximization occurring where MR equals MC, setting output at quantity profit max, but also how when a firm is in monopoly power, they might have the ability to lobby government. If you read more about Boeing, they were able to lobby and manipulate the government regulators, the FAA, so that they're essentially regulating themselves, that Boeing is regulating themselves, which is just crazy. There's a lack of independence between the government independently regulating this monopoly. And so they were able to get away with cost cutting on safety and standard. And that's all in the drive to reduce the ATC curve, bring it down, which is also going to reduce the supply curve, and that's going to increase the supernova profit. In graph C, which is from the previous video, we linked this to asymmetric information. The airline industry at D1, they're placing orders for the 737 MAX, unknowing that it's a defective airline that raises price to PM. It increases producer surplus for Boeing. But as a result of the crashes in 2018, 2019, I believe, and recent investigations, the demand for the 737 MAX is decreasing with more symmetric information, which is taking us from, let's say, point A to point B, reducing price, reducing quantity, and reducing the producer surplus for Boeing. Now that demand is decreasing for the Boeing 737 MAX, the airline industry is going to look for a cheaper alternative. All right, so we can highlight here that there is a decrease in demand. Demand is decreasing with more symmetric information. And as that demand decreases, it's going to cause the airline industry to seek a substitute. So they're going to switch demand now over to the Airbus A320 commercial jet family, and that's going to increase demand on the Airbus side. Before we look at the supply curve. Well, actually, let's go ahead and illustrate it. So according to the Financial Times, it highlights that the Airbus and both Boeing supply curves are very inelastic. For the sake of simplicity, I'm just going to draw the supply curve here. All right. Although the supply curve would intercept the y-axis at a negative value that wouldn't occur in the real world, we're just going to do that for the sake of simplicity. So here we have supply. Graph D, market for Airbus, A320 commercial jets from Airbus. Supply equals marginal cost. And here we have a relatively vertical supply curve. That inelasticity we're required to know as IB students. We need to know the determinants of the PES, which are stated here. Determinants of PES, price elasticity of supply, could include length of time. And definitely in the case of Airbus, length of time is one of the factors. It's going to take them time to increase the quantity of outputs per month. They're producing about 50 jets per month. And they're hoping that with some investments in the long run, they could increase it to 75 jets per month. But that takes time. So length of time is definitely a factor that's causing the supply curve to be relatively vertical for Airbus and also for Boeing. Mobility of factors of production. What is the ease to which Airbus can transfer or reallocate resources from the production of one type of good to another? That could be an issue. Potentially. Another issue here is definitely spare capacity. Does Airbus have idle or unused capital goods, machinery, and tools? Unlikely. They're producing the most that they can, 50 jets per month. They probably lack spare capacity. They're probably at what we call full capacity. There's a lack of extra unused resources for them to employ more variable inputs and produce more outputs. So definitely spare capacity, lack of spare capacity is a factor causing the supply curve to be relatively inelastic. Ability to store stock, probably not an issue. As soon as Airbus produces one of their jets, they probably immediately deliver and ship it out. They don't want to have a lineup of jets in storage. That's going to cost them a lot of money, so that's probably not an issue for them. And the rate at which costs of inputs change, the rate at which the resources they need to produce the jets changes as it rises and falls. Or let's assume that's not really an issue. So the main issue is probably length of time and spare capacity. The article, the Financial Times article, also highlights this concept of supply capacity, that Boeing and Airbus have supply capacity issues, and supply capacity as a term is the maximum quantity of output a firm can produce and supply to consumers, in this case the airline industry, within a particular time period. It's determined by the firm's ability to source inputs like labor and primary commodities. In order to produce and manufacture a commercial jet requires probably high-skilled labor, engineers, mechanics. It may not be easy to source or train that labor resource. Primary commodities, and also the level of productive efficiency that they have and the amount of spare capacity, which links to this concept. So let's review. What is price elasticity of supply as a formula? It's the measurement of the percent change in the quantity of supply divided by the percent change in price. And if we have an inelastic supply curve, the PES value will be less than 1. Right? So for example, let's say that the PES value is equal to 0.7. So let's think of that in terms of this formula. 0.7 over 1. All right? So that's the percent change in the quantity over the percent change in price. So if price increases by 1%, then the percent increase in quantity is only going to increase by an amount less than 1%, let's say 0.7%. Not very responsive. We would see that the percent change in price would be greater than the percent change in quantity of supply. The change in price greater than the quantity of supply, and we can illustrate that on an exam. So here we have Airbus with a particular price set at P1, price 1, with the quantity supplied at Q1, and there's increased demand by the airline industry. They're shifting the demand inwards for the Boeing 737 MAX and increasing it for the A320 commercial jet. Tastes and preferences have changed. They prefer less defective 737 MAX planes, and they prefer more of the safer, higher quality A320 commercial jet family. That increase in demand is going to lead to a rise in the price. So price goes up, let's say, to P2. Quantity supplied increases slightly to Q2. We can see visually that the distance between P1 and P2 is greater than the distance between Q1 and Q2. Again, highlighting that the percent change in price is greater than the percent change in quantity of supply, thus providing a PES value that's going to be less than 1. That's going to be inelastic. Boeing not able to respond quickly and increase in their output as a result of an increase in demand. I can go ahead and illustrate the demand curve. The airline industry switching towards Airbus as a safer alternative. Originally, we have S1, D1 equal to marginal benefit. We have that initial equilibrium at point A, and then demand shifts out in the short run for the safer Airbus model, D1 to D2. Holding price constant in the short run. Here we are at point B. Here we are with quantity. Let's say I'll change this to Q2, and we'll change this to Q3. Okay, so here we can see that at the steady price of P1, with the increased demand from D1 to D2, there's a shortage. We can see that at Q2, quantity of demand is greater than the quantity of supply at Q1. There's excess demand. That's going to put upward pressure on price. That's going to enable Airbus to invest more in expanding their production, employing more resources, maybe investing in more capital goods like factories to expand their production and go from producing 50 jets a month to 75 jets a month, but that's going to take some time. They're able to raise price, reallocate resources at that higher price, perhaps as a reduction in the quantity of demand for the Airbus jets until we reach a new equilibrium at point C in the long run where S1 equals D2. Okay, so that's the goal of this video, just connecting that inelastic supply curve in the context of the airline industry. Generally speaking, when we have manufactured goods, the supply curve is elastic, but here is an exception. Here we have a very complex output, making a commercial jet extremely complicated, very time-consuming to produce. So in this manufacturing of air jets, the supply curve is actually inelastic. And that's it. If you have any questions, feel free to comment those questions below. And don't forget to subscribe and to like. Thank you so much.